Hello, in the previous video I told that every sigma algebra is an algebra, but not every algebra is a sigma algebra. Now I am going to show an example and justify my claim. See what I am doing, I am taking the set of all natural numbers n and I am defining omega as the collection of those subsets of n which are either finite or have finite complements. Now as you can see that the null set or the empty set is belonging to omega. Why? Because its cardinality is 0 and it's finite. Similarly, the whole set n also belongs to omega. Why? Because its complement is the null set, which is phi, and which is finite. So the first condition is satisfied. What about the second condition? We are taking any arbitrary set A which is a subset of n and which is belonging to omega. Now if A belongs to omega, either it will be finite or the complement will be finite. So I have two subcases, right? So let us analyze the first subcase where A is finite. See, A can be written as the complement of A complement, okay? And since A is finite, the complement of A complement is finite. And since the complement of A complement is finite, A complement should belong to omega from the definition. What about the second subcase where A complement is finite? See, if A complement is finite, I have nothing to prove. Then it should already belong to omega. Isn't it so? As you can see from the definition. And what about the third condition? Third condition was about finite union, right? That omega should be closed under finite union. Now what I am doing, I am taking any two members of omega A and B. Now there are three subcases, okay? The first subcase is that both will be finite. So if both will be finite, then their union should also be finite. Isn't it so? So A union B is also finite, and since A union B is finite, so it should belong to omega. And what about the second subcase? See, the second subcase is that both have finite complements. Okay. So I am taking both A complement and B complement as finite sets. In that case, we also know that the intersection of two finite sets will be finite. So A complement intersection B complement is finite, and since that is finite, it should belong to omega. Okay, and we have already proved the second condition holds valid for omega, and so the complement of this should also belong to omega, and from De Morgan's law, A union B belongs to omega. Now coming to our last subcase where one of them is finite and the other one has finite complement without loss of generality. Now see what I am doing. Even if A is finite and A complement is infinite, if I take the intersection of A complement with B complement, it should be finite. Why? Because see, A complement intersection B complement is actually a subset of B complement. Isn't it so? It automatically follows from set theory that A complement intersection B complement will be a subset of B complement. And since B complement is finite, its subset should also be finite. And so it should belong to omega. And by applying De Morgan's law, again I have A union B belonging to omega. That is, the finite union condition is also satisfied. So what can I say? I can say that yes, omega is an algebra over n. Okay. So I have proved this, but now I want to show that omega is not a sigma algebra over n. How do I show that? See. I know that the finite sets are belonging to omega. That means all the singletons are belonging to omega. That means 1, 2, 3. And let me take the odd singletons. Okay. All of them are belonging to omega. Why? Because they are finite. Okay. Now, have you noticed one thing, that if I take their union, what do I get? I get the set of odd natural numbers. Okay. Now, is this finite? No, this is not finite. The set of odd natural numbers is infinite. Okay, so what about its complement? Its complement is actually the set of all even natural numbers. That means if I take this as a, then a complement is nothing but 2, 4, 6, 8 and so on. See, neither of them is finite, and since neither of them is finite, so a does not belong to what? Omega. Isn't it so? And so what can I say? That omega is not closed under countable union. And since omega is not closed under countable union, so omega is not a sigma algebra, even though it is an algebra. Okay, so I hope you liked the video and you understood the example. And if you like watching my videos and if you understand through my teaching, then do subscribe my channel and don't forget to like and share. Thanks.